Okay, so today we're going to cover Chapter 10, Section 3. And what we're going to do is we're going to be looking at a um, hypothesis test for a population mean, right? So 10.2 is a sample hypothesis test for sample proportion, right? So 10.3 is a population mean, very much like what we did with confidence intervals. We had a sample proportion and then we had a mean, right? So let me bring up my calculator. Let me pause here. All right, so if you're watching this, again, make sure you hang out at the very end because there's some important information we'll talk about, okay? All right, so to test hypotheses regarding the population mean, assume that the population standard deviation is unknown, okay? We use the t distribution rather than the z distribution, and when we replace sigma, the standard deviation, with s, the standard deviation of the sample, we get the following equation, right? So, um, I'm going to test there. Did it take us off shared screen? Cuss. All right, so we get this equation, uh, which would be really t sub 0, uh, and which would be uh, our t value that we're going to be looking at, okay? And it follows the student's t distribution with n minus 1 degrees of freedom. Remember that n is the sample size, right? So if it was 35, the degrees of freedom would be 34, right? So just another set of formulas. But again, these formulas are only for you to reference by because we're going to do this on the calculator, okay? Now, properties of t distribution. T distributions is different from for different degrees of freedom, right? So we've got degrees of freedom that come into play here. T distribution is centered at 0 and is symmetric about 0. Basically saying, okay, it's normally distributed, right? So, and what I mean by normally distributed is the bell-shaped curve, right? The area under the curve is 1 because of the symmetry, and the area under the curve to the right equals 0 equals the area under the curve to the left. So basically what they're saying is, okay, it's still normally, right? So I got 0.5 here and 0.5 there, right? As t increases or decreases without bound, the graph approaches but never equals 0, okay? So the area in the tails of the t distribution is a little greater than the area in the tails of a standard normal distribution because s, as an estimate of sigma, the standard deviation, introduces more variability to the t statistic, right? So if you remember when we were doing confidence intervals, the difference between a one proportional z interval compared to a t interval was uh, the variability. The tail portion on the bell curve actually went out longer, right? It was more of a safer bet, so to speak, than a z interval, confidence interval. Okay. As the sample size n increases, the density curve of t gets closer to the standard normal, right? We saw that. All of this is basically repetition of things and theories that we've talked about when we were doing t intervals, okay? This results because, or occurs because the sample size increases, the value of s gets closer to the population standard deviation, right? By the law of large numbers. So, with that being said, let's look at testing hypothesis regarding the population mean. So to test a hypothesis regarding the population mean, we use the following steps, provided that the sample is obtained using simple random sample, right? So there's some stuff that you got. So random sample, the sample has no outliers, and the population from which the sample is drawn is normally distributed, or the sample size is greater than 30. Okay, that's key. This one right here, all of these really are key characteristics, and the sample values are independent of one another, right? Remember on the Z, on 10.2, we basically had to do NPQ greater than or equal to 10, right? Normally, or simple random sample, independent, but this had to be greater than 10, right? But for a t-test, it is a t-test because we're looking at the hypothesis testing for a population mean. We don't look at that because that is for a sample proportion, right? This right here is the requirements for the population mean. Okay, sample size has to be greater than 30. So, just a little bit of new stuff to kind of take in, okay? This shouldn't be any surprise to you. Determine the null and alternate hypothesis. Again, the hypothesis can be structured in one of three ways. Guys, we can have a two-tail, right? Where it's like this, and it's got area over here, and it's got area over here, right? But it matches this condition right here. And note that if we go through all of our null hypotheses have an equal, right? It has to have an equality statement in it. Again, it could, different textbooks will use greater than equal to, less than equal to. It's the opposite of the alternate hypothesis, right? So, and just kind of make sure that you're aware that, okay, two-tail is when the alternate is not equal to the hypothesis. I mean, there's change, but they're not saying it's greater or less, right? Less than. And then the left tail, it's got to be less, right? Or it's decreasing from the null, or it's greater than the null, right? So mu 0 or mu sub naught is the assumed value of the population mean. Okay, so again, if you want to know what mu naught is, we look at the null hypothesis, and it's right here. Okay, and it's going to be that value. All right, so select a level of significance alpha depending upon the seriousness of making a type 1 error, right? So we said that the alpha, again, is basically 1 minus the confidence interval, right? So if you said you had a 95% confidence interval, your alpha would be 5%, right? So just kind of be aware of that. That's the relationship between those. All right. Any questions before we leave this? Anybody? There's 9 of you on here. So this is really everything. Just kind of seeing. Okay, everybody. This is really very similar to what we just did on the other. Okay, the testing. But we're going to look at it in a t-test. So I'm going to point out some things that are going to need to be clarified that's going to help you in 10.2. All right. So you do something real quick. All right. Now we can rock and roll. Let's just get my calculator for me. All right. So we've got 2 approaches. Okay. We've got a classical approach, and then we're going to have a P approach. And we're going to talk about that because I really didn't do a good job looking back at 10.2. So I'm going to point out some things that are going to do and make a little bit more sense, okay? T sub naught, x to the mean, or x bar minus the mean of the mean of the sample over the standard deviation divided by the square root of n. N is the number of things in our sample, and which follows the student t distribution with n minus 1 degrees of freedom. So once we find that, right, that's this t sub 0, we're going to basically have to look it up and find out in the table. Now, that's if you're doing it by hand. right? Use the table to determine the critical value. Okay, so what are they talking about when they talk about critical values? So if you're looking at uh, a bell curve, and let's just say for grins and giggles, uh, let's say it's a left, right? So here's your critical, T sub C, right? Or you could put T sub 0, it doesn't really matter. But that's my T critical, right? So here's my critical region. And if what we have falls in our critical region, then we're going to reject the null, okay? So we're going to show how to get this value a little bit easier. And then we'll also be doing it on the calculator and show you what steps, okay? But here's the formula that is used on a classical approach, doing it by hand for T, looking at a T distribution, okay? And you've got charts and there's problems in your homework that will say look at the chart, but we'll just do it by the calculator. I'll show you some cool things, okay? All right, so again, here's the two-tail. You got critical regions on each side, and note that this critical T value is negative here but positive over here. So let me mark that. You've got a negative and a positive. They're going to be the same values, right? Okay, so just be aware of that. Your critical region here, and I copied down the right twice. I mean the left twice, sorry. Let's go right tail, and we'll go here, right? We're going to say critical and this is going to be T alpha, right? Or the critical T right there. All right. So, so that's what we're looking at. You can look at it here with comparing the critical T's, right? If the T sub 0 is less than the T critical, or T sub 0 is greater, and everything. Now your calculator will find that critical T, and it will also give you the T sub 0. All right, that T alpha is also that's a critical T. All right. Okay, the P approach, same thing, but we'll approximate the P value. Okay, we'll do the same calculation, same degrees of freedom, and here it is for a two-tail, left tail, and a right. So if the p-value is less than alpha, we will reject the null hypothesis, right? But if it's greater than alpha, we will not accept or do not reject. I guess it'd be correct way would be do not reject the null hypothesis, and then you state the conclusion about the claim. Okay, so let's kind of look at this one. So we've got assume the resting metabolic rate of healthy males in complete silence is 5710 kJ per day. What was that? Kilojoules, or I don't know. I don't know what kJ is. Maybe some of the y'all nursing or in the medical type stuff. It's kilojoules. All right. Did I initially say kilojoules? Oh, all right. Thank you. Researchers measured the resting metabolic rate of 45 healthy males who were listening to calm classical music, and found that their mean resting metabolic rate was 5708.07 with a standard deviation of 992.05, right? So let's kind of look at this, all right? We got an H sub 0, we got an H sub 1, right? Our mean is going to equal, well, the mean they say is 5710, right? Now, they say that, and we'll do this, Let's pull out the rest of this stuff. We've got, I want to do this. So I've got an N. So that's 45, right? This right here is our X bar, right? Which is 5708.07. And then we got standard deviation of X bar of the mean, right? Of this mean sample is 992.05. Okay. We have an alpha. We'll just do this alpha of 0.05. That's important. The alpha is what we're going to use to do the T. All right. Not the T, but the P value. Okay. That's what we're going to compare. All right. At the alpha 0.5 level of significance, is there evidence to conclude that the mean resting metabolic rate of males listening to calm music is different than 557.10 kilojoules per day? So my question is, it can't be an equal. I shouldn't put that. Let me do this. That's the null hypothesis. That's 10.1, right? You know, 10.1 set up how to determine your null and how to determine your alternative hypothesis, right? So, yep. So if you're still a little confused on that, look at that, okay? All right. So looking at this, we've got, for our alternative hypothesis, if the mean is equal to 5710, their claim, is there evidence to conclude that the mean resting metabolic rate of males is 5710, is different than 5710. Notice that they didn't say it was greater or less than, right? They just said it's different. So that would be not equal to, which would be a two-tailed test, right? A two-tailed test. So let's kind of look at this, okay? So if we do two tails, and this is really what I need for you to do, is to kind of look at this a little bit closer. You've got this area here and this area. Now this 0.05, this is going to be your alpha divided by 2, so that's really 0.025, and then 0.025 over here, right? This area, right? That's on each side of that, okay? Any questions about that? Anybody? Now, did they give us the degrees of freedom? I don't think they gave us the degrees of freedom, and I really need a degrees of freedom on this to be able to do what I need, unless they gave it to me on the next page. Let's think about this. Did they give it to us? Nope. Nope. And nope, 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 nope. Oh, yeah, they did. Duh. Come on, Tommy. Degrees of freedom is n minus 1, which is 45 minus 1, which is what? 44. Okay. So let's find these critical values right here. So how do I do that? If you remember when we were doing the T intervals and stuff like that, we were looking at here's a confidence interval, trying to find that, which gave us the area underneath the curve. What is the T value on the distribution? So if we were to look at it, we would be looking at it as 0.25 with a degree of freedom of 44. Okay, in that in the table. But what we're going to actually do is we're going to do this. We're going to say second bars, and if you look at number 4, that says, okay, what is the area underneath? Well, it's 0.025, right? 2.5%, right? And our degrees of freedom, we said, let's see, hold up. There's 45 people, so 45 minus 1 is 44. So we're going to put 44, and then we're going to hit enter again, and we'll hit paste. But boom. Now it gave me negative 2.0154. Okay. Now what do we do with that number? Negative 2.0. Let me write that down because I didn't. All right. So you've got to understand that there's two places that is. That's negative 2.054 and then positive 2.054. Okay. Now, if it is less than this, in somewhere over in here, well, let me mark it with a. If the values that we calculate from doing the T test are in either one of these regions, then we will reject the null. Okay. But if it's not, then we will not reject the null. Okay, we're not going to accept it because there's too many parameters of unknown stuff to be able to say about the population. We're just going to say either we're going to reject it or not reject the null. Okay, so how does, we're doing a T test, right? T testing on a hypothesis. How did what I just done to find these critical T values right here, how does that compare to 10-2 with a Z or one proportional Z test, right? You can do, with our alpha levels, if you went and did, once you find and drew it out, whether it's a left tail, right tail, or so forth, two tail, you could go to a number 3 where you would put the area underneath it, right? On mine, it says left, center, or right. That's talking about the tail. But if you say left, then if it's on the right one, you just make it positive, right? Take absolute value of it. But you could find that Z value there, okay? And that would correlate to what our T critical values are here, right? Here's our T sub C here and our T sub C here. T criticals. Any questions about how I come up with those critical T values? Anybody? Is what I just done, I mean, do y'all understand how I got to 0.025? It's an alpha significant level of 0.5, which means it's a 95% confidence, right? So right now, there's 95% right there, right? So we're testing to see if it's going to be, outside of our confidence interval. It'll be a type 1 error. It'll be in the alpha region. So are y'all good with how I came up with the T sub C's right here, these critical values, to be able to test? Yay or nay? Oh, that's a good question. Do you see all this stuff that I just got written in green over the left-hand side right here? The number of my sample, the mean, the standard deviation of the mean, and degrees of freedom and stuff. All of that we're going to put in the calculator, and we're going to tell it it's a two-tailed test, and we're going to calculate it. We're going to come up with two things. It'll give us a T sub 0, which is our value to go and compare against our critical T values, which would correlate to our Z number or Z sub 0 from 10-2, and our P is going to be the same, right? It's the same approach in either way. And we'll talk about what that, you can do either one. It really doesn't matter which one you do. I can do a P and not even have to worry about my critical T's or critical Z's when I draw it, okay? But we'll talk a little bit more about that. Here's this. I need to now, let me write this down, and hopefully you're writing this down too, or at least 45. Mu sub 0, we need the mu sub 0, and that is up in the null hypothesis. That's the 5710, okay? X bar is 5708.07. Standard deviation of the mean sample is 992.05. and degrees of freedom equals 44, and the NS said was 45. All right, so here we go. Y'all ready? Good stuff right here. So we've got everything that we need. So what we're going to do now is we're going to come over to our calculator, and we're going to go, let me erase this. We're going to hit stat, and of course we're going to test, right? So I'm going to hit arrow to the left, which gets me there. Now I'm going to hit number 2. All right, number 2. And it's data or with stats. So you could do either one, okay? The data would be pulling from like L1, L2 type stuff, right? From list. So you can put all your stuff in there and it'll do it for you, right? If you know the stuff, if you've already done some calculations ahead of time. But we're going to look at the statistical data. The mu naught, right, is the same. It's 5710, right? That's in your null hypothesis. It'll always be that. Mean equals mu naught, right? That came from the notes. And then with X bar, we said X bar was what? 5708.07. And then the standard deviation of the mean sample was 992.05. And then how many were in our sample? Well, there's 45 of them, right? There. Now, from here, we've got two-tail, left or right, okay? And this happens to be a two-tail, all right? So now we just go down to calculate. But before I hit calculate, any questions about how we're doing this? Any questions at all how I just took the data and put it in there? Oh, good question. Right here, our statement, our claim, at an alpha of 0.05 level of significance, is there evidence, this is our claim, to conclude that the mean resting metabolic rate of males listening to calm classical music is different than 5710? Okay, so they're stating a claim. They're saying, is it different than 5710? So if they just say, is it different, they're not saying whether it's greater or less than, right? So they're just saying, you know, does it not equal 5710? So when they say that, then that means it's a two-tailed test, right? If it's decreasing or if it's less than, then you're looking at a left tail. If their claim says, is it greater than the mean, then you're looking at a right tail. Okay? Yeah, not a problem. All right, so let's go back to our calculator here. We got everything in here, and we'll hit calculate, right? Boom, enter. All right, so let me show you these two values right here. Here's our t sub 0. This is what that formula back on the classical approach gave, okay? Negative, if you do that, it'd be negative 0.0131, okay? Now, that's our t0, 31, and then we got a p-value of 98, 96, right? Now, boom. You ready? Let's go back to our drawing, because I got to fill in some stuff. Now, we got a t sub 0, right? We got a t sub 0 out of our calculator that said it was negative 0.0131, right? Okay. Now, where does that value fall with respect to my chart that I just graphed up here? Look at my T criticals on the left and the right. Do they fall in those regions? Does that negative 0.0131 fall within there? Does it fall in the yellow? It doesn't. That's exactly right. If it did, then we would reject the null, right? Okay. If it fell in those regions, we would reject it, whether it was negative or, guess what, positive. So it falls in here, right about in there, right? Somewhere in there. So we would not, okay, our claim would be We would not reject the null hypothesis because there's not statistical significance that the mean resting heart rate, metabolic rate for males listening to classical music is different than 5710 kilojoules. Okay, so we would not reject the null hypothesis. Okay, y'all understand what we're doing with this T sub 0 that we got from the calculator. We're comparing it against our criticals, right? And that's what you could do with a 10.2 if you wanted to do the Z values, right? You could find the area, the critical Z, and you could do that same thing. Now, that's one way to do it. But let's talk about what's called p-value, okay? Because we got a p-value, did we not? And we're going to compare the p-value back to the alpha. So our p-value that we calculated, or we didn't calculate, our calculator calculated was 9896. How does that compare to a 0.5, right? It's what? Much greater, right? It's much greater. So if it's much greater, if the p-value is greater than alpha, then we will not reject the null hypothesis, okay? If it's less than, then we would reject it, okay? Do you see there's two ways to determine whether you reject it or not? I didn't do, looking back at this compared to Monday night, I didn't do a really good job nailing that down when I taught the Z, okay? So there's two tools that you can use, a p-value or a T sub 0 value, right? But you've got to have, they require different components. The easiest one is just to compare the p-value against the alpha, right? That you don't have to find critical T values or critical Z values, depending upon what are you doing. So again, that's my thoughts. So any questions about this? I highly recommend, if you really want to fully kind of wrap your mind around it, draw this right here, a little chart, this little normal curve, put your critical values in there, do all of it, do both ways to make sure that you haven't made a mistake. It didn't take long to do that p-value, right, after we done the T, and it just validates it. Okay, so let's go over here. If y'all ain't got any questions, let's go see what the solution ought to be. Okay. All right, so they got negative 0.013. And did we get negative 0.013? Yeah, we did. That's our T sub 0, right? Right there. Y'all see that? T sub 0 down here in the green, negative 0.013. I went to 4 decimal places on my calculator. All right, so do you see the negative 2021 and positive 2021 here? Let me grab a highlighter. They went to an alpha of 0.5 significance with degrees of freedom of 44, right? So they came up negative 201 and positive 201, or 2.021. So let's go see what we did here. I calculated it based off of the calculator. So my critical values are going to be just a little bit different, right? But they're not going to come into play from a standpoint of whether we're going to reject or not, okay? What do we have? 2.02, so we were at 300ths off. So not bad. Now, so we failed to reject the null hypothesis, right? Because it's in between the two critical values. It's not in them, but it's I want to say it's in between. It's right in here, right? Use this. It's right there, right? And we said do not reject the null hypothesis, right? So you look over here, We failed to reject the null hypothesis. So we come up with the same thing. All right, now, did I do this one? There's insufficient evidence. They just went ahead and wrote the claim. There's insufficient evidence that an alpha of 0.5 level of significance to conclude that the mean resting metabolic rate of males listening to calm music differs from 5710 kilojoules, right? So that's the statement that you're making. You're either rejecting the null or accepting the alternative hypothesis, right? So, well, these are the T criticals here, the negative 2.054. You can do that's the inverse T that I did on the calculator with a second distribution, right? Or second bars, which is distribution went to number 4. That's an inverse T. If you got the area underneath the curve, you can find out what its T value is very quickly by doing the inverse of it. And right above it, number 3 is the inverse norm, right? Which is a Z score, right? So those two things are very, very critical in 10.2 and 10.3 doing. So I'm not having to look it up in the table because my calculator will calculate it for me. You could, right? I mean, when you're working on your homework problems, they have that T distribution and for criticals, and you can look at it and go through the alpha and go to the degrees of freedom, and you can pull those numbers off. And I highly recommend you doing that just to kind of see and compare to what your calculator. But I'm going to go with what my calculator has, okay? Did that answer your question? Yeah, good. All right. So there we go. That now the p-value, we've already looked at it. They only did this. I don't agree with. Well, that's the significance. They got a 0.5 p-value, but our p-value was like 0.98. Use calculator's p-value. We're not going to calculate the p-value per se, all right? But the p-value is really the probability, okay? So just know that that's what the p-value is. It's talking about a probability of something happening or not happening, okay? So when they give you a probability of something, that's really what it's meaning. It's really meaning, okay? All right. So here is its solution approach, and we got something different here. We got what 0.98 something. I don't know what it was. Yeah, 9896. Sorry. So I don't know why they're different. I'd have to nerd out with some of my colleagues on why that's different than what's on the calculator. But just use the calculator and you'll be fine. Okay. All right. So really, that's it. That's it in a nutshell. So let's I want to kind of go back through this, just kind of summarizing. They gave us a mean, right? They said that, hey, it's 5710, and then they started giving us some sample information, right? Our X, our mean of our sample, our standard deviation of a sample, how many people were sampled, right? We've got the degrees of freedom here. And then we were able to write our null and alternative hypothesis. Now, our alternative hypothesis is written based off this claim right in here, right? The different, it didn't say greater than or less than, it just said difference, a two-tail, right? And that mean, this 5710 is the mu naught, right? And the null, here's something to make it a little bit easier. Your null will always be the mean equal to the mean of the population. Okay. and it always have an equal. So you just got to decide on the claim for your alternate hypothesis. Are they looking at it whether it's going to increase, decrease, or just be different than the mean, right? And those are your three considerations. Okay. All right. And again, we found the T criticals. You can find the Z criticals in 10.2 by doing the inverse norm, right? And then we performed the test, hypothesis test, and got T sub 0 and compared it. And then we compared it with the p-value in alpha, right? So you would be doing that in 10.2, but you would be doing it with a Z value, a Z distribution, because you're looking at a proportion, a sample proportion. We're looking at a sample mean, and that's the difference. Remember when we were talking about the means and confidence intervals? If you talk about the means, we're talking about a Mr. T, right? Y'all remember that? Mr. T from the A team, right? So, all right. So let's kind of look at this, and I apologize for it being so small, but I had to grab as much information as I could. These problems are going to give you, a majority of them are going to give you everything you need. Okay, they've given you here your null hypothesis and your alternative hypothesis. Okay, so you got to know how to read them. You got to know whether it is a two-tail, left tail, or right tail. And looking at this, what would it be, folks? What would, just comparing, the alternative hypothesis? Would it be a dual or two-tail, right or left? So I heard some lefts, and I agree because it says the mean is less than 40, right? You see that? So that would be a left tail. So if you looked at that, and we will, that'll help us draw, right? Our sample size is N, is 26. And they've given us, you can click here to find stuff if you want to read the T distribution for the critical values, right? You can do that. And I highly recommend you, but we're going to calculate it on the calculator as well. They give us X bar and they give us the standard deviation of the sample, right? So everything that they've given us, what we need is this, mu naught, X bar, S of X, and then N, and then we need to tell what is it. It is a left tail, right? So if you think about this, we got to fill these things out. And if you write these down, it'll be a little bit easier to when you plug it into your calculator. So that mu naught is the same as the value that the mean's equal to in the null hypothesis. So that would be 40. And then our X bar happens to be 36.8. And then our sample mean distribution is 14.2. And then they did 26, right? They sampled 26. So a left tail proportion. Okay. So let's do some things real quick. Did they give us this? Yeah. Okay. They're not going to give you on this problem right away. They're not going to give you part B. They're not going to give you the alpha yet. They're just going to say, hey, find T sub 0. So we can find T sub 0. It's not a problem. We can go do that. If you go to your calculator real quick, you can perform the t-test. You got all the information you need to perform it. You just need to have some more information to be able to do analysis with it, I should say. All right, so we're going to clear here. All right, clear, boom. If we go stat, arrow to the left of test, we're going to go 2, right? And if you see all this stuff, it's all right there, right? Mu naught, that's going to be 40, right? Our X bar was 36.8. Our stat. You go stat. So your three options when you hit stat are edit, calc, and test. So you want to scroll, you want to hit the arrow either 2 to the right or 1 to the left because it's cyclical, which means if you hit left, it'll just continue wrapping around, right? And we went to number 2, right? Okay. And then we're just going to put our information in. We're on a sample distribution, a sample standard deviation right now of 14.2, right? And then our number in our sample was 26, right? Now, these comparison is two tail left and right. And we said it was a left tail, right? So we're going to make sure we highlight it and hit enter. And then we'll go to calculate. So any questions about putting in what we just got or they gave us from the problem? Anybody? All right. So when you do this, you get a t sub 0 of negative 1.1491. And then you also got a p-value, right, of 0.1307. Those two bits of information you need to pull off of your calculator and write down because that's what you're going to use, okay? Because we're going to do some analysis, but they got to give us an alpha, a statement of significance, right? Or they got to tell us it's a confidence interval, right? One of the two they got to give to us. So let's go look. They want t sub 0, and t sub 0 that came from the calculator is negative 1.149. Okay. Now it said round to 3 decimal places. So folks, round to 3 decimal places and make sure it only has 3 decimal places in it. Okay. Your calculator would do that by just hitting mode and then selecting 3 to the right of float and hit enter. It'll automatically do it for you, so you don't have to worry about the rounding rules if that trips you up. So there's where t sub 0 in, right? You hit enter, boom, it'll tell you, great, good job, good work. Now, part B pops up. Now, this is where we're going to do the analysis. It says if the researcher decides to test a hypothesis with an alpha of 0.1, that means this right here, area is 0.1, right? That's my alpha. That's the area underneath the curve, right? Right here. Determine the critical value. Although technology or a t distribution table can be used to find in this problem, use the t distribution table given, right? Well, they say use that, but I use the calculator. Okay, so let me show you what we're going to do. This is where we're going to use the calculator. We know that, well, we have to have the area, right? So it's inverse, let's see, inverse t. And so we have to have the area, the alpha, and then degrees of freedom, right? Those are two things we got to have, right? So if we do this, we got it, it's 26, so degrees of freedom is 25. So alpha is 0.1. So we're going to hit second bars. Oh, cuss. Come on. Let me clear ink here. Second bars, which gets us to our distribution stuff, right? We want to go inverse t. It is 0.1, right? Enter. And let me make sure. Yes, alpha 0.1 and degrees of freedom would be 25. So, and degrees of freedom would be 25, right? Hit enter, boom. We get negative 1.316, right? So that's our T critical right there. That's what's going to go right here. That's its value right here. So that is negative 1.3163. Okay. Do you see? And that's what they wanted just to know, just 3 decimal places, right? Now, what we have to do now, because we've got a, let's see, we had a T sub 0 of negative 1.1491. We also had a p-value of 0.1307, right? So, those two things are what we're going to use to do analysis with. Now, where does the negative 1.1491 fall with respect? Does it fall in the red, or does it fall outside of the red? It falls outside the red, right? It's somewhere over in here, right? Does everybody see that? If we're comparing this t sub 0, where does it fall? It's somewhere in here. So it's not in my critical region. So we do not reject the null, right? We do not reject the null hypothesis. Okay. Now that's doing it with the t value and a t or t sub 0 and a critical, right? We're going to do it also with the p. So we have a p-value of 0.1307, and then we had an alpha of 0.1. Okay. Now, when you compare these, here's the p, here's the alpha. The p is greater, right, than the alpha. If that's the case, then this is our conclusion. The same thing, right? So there's two ways to analyze it. You could do it with a critical t, right, and find the t sub 0 and see whether it's in the critical region or not, to accept or not reject the null hypothesis, or you can do it with a p-value. So there's two paths that kind of run parallel, but they're looking at two different things, okay? And I'm about to bring it up. That's what I had typed into mine. Now, did you have the left tail selected? You have to select what proportion test you're going to be doing, right? So that's a two tail, that's a left, and then that's a right. So I want to make sure when I do this, and I'll show you something, I'll point this out. When you hit this, do you see up at the very top, the mean is less than 40? Do you see that? Okay, our claim over here was what? The mean was less than what? For the alternative hypothesis, less than 40, right? So if that doesn't match, your alternative hypothesis, then guess what? You picked the wrong tail. Does that make sense? So that's also a checkpoint, because Monday night I even made that mistake. I thought I clicked it and it didn't. It came up with a different value. And it will come up with a different value. You'll be like, I know I typed this stuff right, but you got to pay attention. Make sure that first statement, when you hit to get your t sub 0 and p value, that you look at that statement and it is identical to what you're looking at here, right here, okay, for your alternative hypothesis. All right. Now, I have said a lot. I've done a lot on this right here problem. But my main thing that I'm trying to drive home this evening is, guys, do you understand that we have two ways to, or when we do a t-test on it, we have two outcomes that we can compare. We have a t sub 0 that we can do an analysis on, right, with the t critical, or we can use the p-value against the alpha. Those are our two analysis fork in the road. You decide which one you want to do. It really doesn't matter, right? But either way is acceptable. It just depends on what the question wants. And this particular question wanted the critical value. When they talk about the critical value, they're talking about the little value right here in blue, right? And I'll highlight that. right here. Okay. And if they talk about it in Z, they're talking about it, do your inverse norm and find that critical Z value and compare it, right? So, all right, so that's that one. So let's go look at another, because you may, the one that you work may have a right tail, may have two tail. I mean, it could be whatever, right? Part C and part D. This is part C and part D of that particular problem. There's 4 parts to it, but you had to pick which one the drawing matched, right? Left tail, right tail, or true tail. That tells you what proportional test you're doing, right? And then what will the researcher reject the null? Well, no, because the test statistic did not fall into critical region. So the blue parts that are listed up in these graphs, those are considered the critical region, right? And if something hits in those, then we will not accept. No, we will reject the null hypothesis if it hits in those criticals, right? All right. So let's look at 10.3.7. I put these numbers up here so that you can reference to the ones that are on your homework as well, because they used a couple versions of these numbers that's kind of played against all of them. I just wanted to make sure that you had enough examples to really get this under your belt. All right, so again, look at what they're giving us. They're giving us the null hypothesis, right? And they're giving us the alternative hypothesis. They're providing this stuff. They even is telling us that, hey, there's 17 in our sample, right, from the population. And they're giving us X bar and the standard deviation of the sample. So every bit of this, they're giving us. But what do we have to find? Well, our calculator wants us to find these things, right? And then I'm going to put proportion. So is this a left tail, right tail, or two tail? Well, it's not equal to, right? It didn't have this right here. So it wouldn't be an alternative hypothesis. It wouldn't be a not equal. So it can't be a two tail, right? So it's either left or right. So is it less than or greater than? There you go. So I'm going to put left tail right here. And if you put this out, you have it, you pulling all, it's more organized. It's everything that it's going to need for the calculator. The mu naught, well, that's mean equals mu naught, right? So that's 20. X bar is the 18.4, and the standard deviation is 4.2, and we have a sample size of 17. Okay, every bit of this right here is everything that I need to do the test in the calculator. Okay, and when I do it, it's going to give me back a t sub 0 of negative 1.5707, which if we got to go 3 decimal places, folks, we're looking at that, right? Okay, any questions about that? Now, I can do it in the calculator if you want me to. Y'all want me to do those steps in the calculator, or y'all good with that? Let's see how many people's on here. We got 10 people on here. So I think I've showed 2 examples on going to put them in the calculator and stuff. You ought to be, if you do this right here, this green stuff on a piece of paper and fill this out and know that's what you have to fill out, then you'll be rock solid. Okay. And these are things that you need to think about when you're creating your, I hate to say formula sheets for the final exam, but you need to be having stuff like that. You need to know what you're looking at and what to hit on the calculator. Okay. All right. So it's p-value. When you do a p-value, when we do this test, our p-value happens to be 0.0679. Now, the next question says approximate to p-value. Choose the correct range. Well, they didn't say put it in. They just said which ones it fall between. Well, it falls between these, right? So make sure you pay attention to your decimals. because you could make a simple mistake by just grabbing, not knowing where it's in between, or if it's in this one, it goes in this one. So just kind of take a step back and go, okay, where is it and which one does it fall between? So there. Now, if the researcher decides to test this with an alpha of 0.5, then will the researcher reject the null hypothesis? So if we look at this, let's kind of do this because we can, right? Kind of spending time. It's a left tail. So I know, and this is just a generic drawing, right? And we got an alpha level of 0.05, which means, hey, that area is 0.05. And if I do an inverse T, and I put 0.05 with, let's see, got 20, I got 17, so it'll be 16 degrees of freedom, and hit enter, guess what it's going to give me? It's going to give me this critical value right here, 1.7459. Okay, inverse T, that's second bars to the distribution ones, right? And it gave me this value right there. Now, where does our T sub 0, does it fall in this critical area, or does it fall over in the non-critical area? Where does this T sub 0 negative 1.571 fall? That's exactly right. So when it doesn't fall in the critical area, then we can't reject the null. Okay, so the researcher will not reject the null hypothesis. Now, they're saying because the p-value's not less. Well, we did it with the t, right? So let's turn around and do it with the p. We got our p-value 0.0679, and then we got alpha of 0.05, right? So which one's bigger, the p-value or alpha? Alpha is, not alpha, the p-value is, right? Which would mean that we do not reject, right? That's what that means. Since the p-value is not less than alpha, we will not reject the null hypothesis. So two things backed up each other's claim, right? The critical T doing it that way, and then with the p-value, right? They're two parallel paths to get us to the same thing. Now, which one do you do? It depends on what the problem asks, right? I have a tendency to just go ahead and do them both. And that way you've got all bases covered. If they give you that alpha, just go ahead and do them both. Fair enough? Any questions on this one? I can't stress enough the importance of the drawing, okay? It really solidifies the whole conceptual idea of what we're doing. So I highly encourage you to do that. All right, again, any questions? Anybody? All right. Okie dokie. Let's look at this one. We've got to, is that the only thing we got to do? No. All right, so this one, we got to read all this stuff, right? So what you get out of this is a couple of things. You got to read it, and you've got to basically fill out the null and alternative hypothesis. Well, so a college entrance exam company determined that a score of 25 on the math portion of the exam suggests that the student is ready for college level mathematics. So here's our mu naught, right? Here's our mu naught. So we've got the mean equal to 25, right? Mu naught. That's our null hypothesis, right? It's always, well, for a t-test, it would be mean. But if you're doing a z, it could be a p for proportion, sample proportion. It could be a standard deviation, sigma, right? And it could be the mean. Just depends on one of the three variables that they use, okay? But on a t-test, we're only doing means. So anybody questions about how we come up with this null hypothesis? It's got to be equal to the mu naught, the mean of the population, right? Now, we keep reading. They give us a sample. They say, okay, it's a sample of 200. We got an X bar of the sample of 25.3. We got a standard deviation of the sample of 3.3. Reading this. Now, Does these results, the last sentence, suggest that students who complete this core curriculum are ready for college match? That is, are they scoring above 25? Y'all see that? They didn't say it's not equal, not 25. They didn't say it was less than 25. It said above. So this would be a right tail, which means the mean is greater than what? For the alternative hypothesis, right? That's the claim that they gave us. The mean is greater than 25. It's above 25. So it's a right tail. Okay. Now, so when we draw this, and yours didn't have to be pretty. I mean, look at mine. You put this, and so we know it's going to be a right tail. Now, we're going to need some other stuff, right? Because we got to know our alpha, right, and everything before we can do this, right? Our analysis. But that's part B. Well, part A. Part B said, there's three things that I said I starred back in the very beginning of the class or the lesson tonight, and I said, hey, these are important things. It's this right here, sample size larger than 30. That's kind of like the NPQ greater than equal to 10 on the Z stuff, right? But this is when it comes to a T, right? So these three things requirements have to be satisfied. So just kind of know that. Those are things that we pointed out, very first thing. Want to go to the part C and D. They say use the p-value approach with a alpha of 0.05, okay? And then they want us to find the t sub 0 and p-value and then perform it, right? So it's a alpha of 0.05. So this alpha is 0.05. Now, I can do this, and when I do this, when I do it, it's going to give me a negative, okay? But this is, so if I do an inverse t, and I go, okay, it's 0.05 with 200, so it'd be 199. It's one less for the degrees of freedom, right? Degrees of freedom is 199, it's one less than n, right? When you do that, it gives you a negative because it's looking at area to the left, right? But if I were to do it over here, this would be a negative 1.6525, right? But when it's on the right-hand side, you just make it positive. Okay, even though it gave me back a negative, it's looking at it in terms of left, right? I know this is right, so this is going to be a positive. So you're going to really, it's kind of like take the absolute value of it. Okay. Now, so when we do this, put this in our calculator, we need, let's see, we need mu naught, and a mu naught is what? 25. We need, what else we need? We need X bar, and that's what? 25.3. We need standard deviation X is 3.3. We also need what type of proportion we're doing, and that is a right tail. No, we got one more thing. Sorry. And back up. Forgot this one. N is 200, and then what kind of proportion of tail is it? And it is a right tail, right? So when you do this and perform this by going to stat test number 2, right? Number 2 for a t interval, you get a t value, a t sub 0 value of 1.2856, and then you get a p value, which is 0.1. Okay. Now, it said to test it. Well, let's just look right here. 1.2856. Is it in this critical region right here? Does it fall within that? Nope. So we will not reject the null. Does that make sense? This didn't fall in that critical region. If it did, we would reject the null hypothesis. Because it didn't, we will not reject it. Okay? But we're also going to take this p-value, and we're going to compare it to our alpha, and our alpha is 0.05. Now, which one's greater? the p-value, right? If the p-value is greater than alpha, then we will not reject the null hypothesis. Okay? So we've done all our analysis right there. So this, and they have multiple parts. So here's the t sub 0, right? And this said, now listen, this said 2 decimal places, right? So you take that 5, makes that 8 goes to a 9, right? Because we got 1.2856. So this is going to make that one go up, right? And then the p-value was 0.100. And see, that said 3 decimal places. And then it says, or write it based on, so we do not reject because there's not sufficient evidence that the mean is greater than 25. Okay, that's our claim. Well, I shouldn't say our claim. We're stating our result of the claim. Okay, it's our statement. Any questions about that? You're starting to see a lot of similarities, a lot of things, a lot of same steps, same approaches. Hopefully you are. This should help you with 10.2. You just need to find the Z criticals by doing the inverse norm of the area, depending upon if you're right, left, or two-tail. And if you got two tails, remember you got to split it, right? And just, you just compare. The calculator do it for you, right? All right. So 10.39. Here's all of our stuff. The hypothesis, they gave it to us, right? The null hypothesis, and then the alternative hypothesis. It says not equal, so guess what? That is a two-tailed distribution, right? Two tails. See that right there? Now, does the population have to be normally distributed to the test, and why? No. It's no because it's greater, and it tells us it's greater. Sample size was 35, n is 35. Okay. I just looked at it and saw the n is greater than, clicked that, and I was like, duh. Okay. So if you do that, you're probably going to click on just going quickly through it anyway. Now, they gave us X bar and S, right? So, it's two tails, right? Boom. And I'm just going to do this. So we got stuff over here, right? Now, there, and we got it over here. So they want us to do a test, right? So we got mu naught, and then we've got what? Let's see. X bar, S of X, N, and then proportion, right? It's two tail, right? N is 35. Standard deviation was 5.8. And then X bar, the mean of it was 104. And our mu naught is right there in our null hypothesis, right? That's 107. And when you do this, you get two things back. You get a t value of negative 3.06, and you get a t sub 0, I should say, and then a p value of 0.0043. Okay, so this right here is going to help make sense. I told you p is the probability, right? P is the probability of it, right? So they said, hey, is the p value between these? So you got to pick which one of these it's between, right? You got your t sub 0 right there. But this down here, notice that if you would look at this would be 0.43%, right? That's if you looked at 100, okay? If 100 be 0.43%. But look at their stuff. They're saying if 1,000 random samples, 1,000, there's 100, and then 1,000. The reason they're saying 1,000 is, look where that is. It's in the thousandths place, okay? So in 1,000 people or 1,000 samples of size 35, are obtained. 1,000 random samples, because look at where it's at. We couldn't say 100, right? Because that's 0.43, right? 1,000 random samples of 35 are obtained. 4 samples are expected to result in a mean as extreme or more extreme than the one observed right there. Okay, so basically what we're saying is four out of those 1,000 samples of 35, 4 of those would be falling within the green regions. Okay, so the probability out of 100 would be 0.4%. Out of 1,000 would be 4, right? So that does that kind of help you with the p-values a little bit? Understanding it's like 4 samples out of 1,000 because it's in the, it's a, if you were to move it and put a percent, it's still 0.4. So that's with 100. So you need to get the 4 out so you can kind of, so that's just another power of 10. So any questions about that? Y'all good? All right. So, and I don't think, maybe they did tell me. No, they didn't. That's the only thing that they said. Okay, we didn't have to say reject or not. We just had to interpret what the P was. Okay, so guys, that's it. That's 10.3 in a nutshell, right there. Okay. Yeah, after I get done with everything, yeah, you sure can. All right, so that's 10.3. So we've kind of looked at everything. I highly encourage you drawing stuff, right? Getting this right here. Creating this right here so that you have like a standard setup of what you need, what you're going to get, right? Talking about critical T values for 10.3, it'd be critical Z values for 10.2. So, excuse me, that you should really have a better idea of how things are working now when you're doing a hypothesis test. Okay, now, so that's all of that. So let's talk about some things. Okay. Now, there is, and let me get to it. And it popped up today, and you should notice that it popped up today. Yeah, I am. Yeah. Want to go through about 3 or 4 things, and then I'll stop recording because there's 10 people that didn't even show up. So instead of me having to put it in a email, say, dude, it's on a video. You should have watched the video. Yeah, no, it's going to be on a video. So, and 2, you have everything you need. So come on now, why did this thing open it? All right, let's go to, is it quizzes and tests? Yeah, maybe it's this. Yeah. All right, so we're going to go right here. I want to talk about, if you go to, I don't know what it looks like on yours, but there's this thing, it's called FER that popped up right here. Okay. And it's your final exam review. Okay. So I've given you 4 times. You can go through it 4 times, but there's about 50 questions, all right, that are from chapter 1 all the way to chapter 10. Okay, so that's really all that your final is going to cover, chapter 1 to chapter 10. There's only one question that was on the final for chapter 12 that had to do with it, and it was a simple question. So I wasn't going to spend a whole hour and a half, 2 hours with the teaching content for one question that took less than 30 seconds to answer. I felt that your time would be better utilized focusing on the review and getting your test at your last test, chapter 9, which is due tomorrow, completed, and then looking back at all your homeworks and trying to get everything cleared out on those. So that's a final exam review. I highly, 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 highly recommend you doing it. You want to prepare for the final, do the final exam review. Don't just do it once, do it twice. Before you do that, go through chapters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Create sheets that say, this is what was taught, this is what was the calculators, stuff, put menus that are showing up, so that you have an idea when you get to one, you know exactly what you're looking for and stuff like that. Please, please do that, okay? Because if not, you're going to have a lot more things on your mind when it comes to this final exam, and you're not going to be able to pull it up. So put the time in while you still got some. Okay, I'm tossing the 2 sections in 12 to give you that time to do that. Okay, so it doesn't count anything. Okay, it does not count towards your grade. So don't ask if I do it 4 times, if I do it 1 time, blah, blah, will it help my grade? No. You want to make a good grade on the final, do it. You don't want to make a good grade on the final, don't do it. Okay, that's about as clear as I can put it. All right. Your test 7, which is chapter 9, it's due tomorrow. Okay. There's 2 main concepts on that. There's confidence intervals for 1 proportion confidence interval, and then a T interval, right? You need to make sure you understand the calculator steps on those and what you need to work those homeworks, get those homeworks done. Okay. So you'll be prepared for the test. You need to hit this one out of the park. All right. Now, that's test number 7, chapter 9. Now, I have went back, and what I've asked y'all is to send me emails that said, hey, go back, look at your test for rounding errors. Okay. So I've got probably, 6 emails from people. That's it, 6 emails. Folks, I don't understand it, but here's your Christmas present. I didn't review test number 1 because everybody done so well on it. Okay. So if there's something that's round off in test number 1, just let me know. Send me an email. But I've looked at test 2 already and reviewed it and gave back partial credit. And I've done test 3, which is chapter 4. So chapter 3 and chapter 4 test, I've already reviewed and gave back partial credit or back credit for round off errors. So you should see, I don't know if you write them down or whatnot, but they should have went up for those 2 tests. Okay. I will review the questions you missed in test 4, 5, 6, and 7. Okay. Before, that's what I'm going to do. Since I code 12, I'm going to take that time and have that. I'm going to have that done before Monday. Do you understand? Now, what are we going to do Monday? Monday is our technically last class. We're going to take questions. You're going to look at stuff. You're going to look at that final exam review, and you're going to ask questions off of that. Okay, that's what I'm going to take questions off of. So there's a lot of stuff in here, and you need to make some sheets for each chapter, because I'm not going to sit there and do that final exam review. Okay, that's yours. Because I don't have to take the final, but I may get to one and go, all right, it ain't clicking. Okay, what do I need to know about this particular chapter? And I'll look through my notes and maybe something. So I may lean on y'all, say, okay, Palmer, you need to do this, right? Okay, so just know that if you hit a problem, I might go, I don't know, because there's 50 problems there, okay? So, and I'm not going to sit there and do a comprehensive review and start doing all that stuff. So a lot of this stuff I haven't seen since middle of October, right? So I'll try to do my best, but I may lean on you to go, okay, what am I not seeing, guys? Okay. Um, we should be okay on 7, 8, 9 chapters and 10s chapters. But the stuff that we haven't seen in a while for me, I may lean on you. Does everybody understand that? What we're doing on Monday? Okay. Now, here's something else. I know that I normally send out a text and say, guys, there is a test that's going to close. I understand that. But I also understand this right here. That if you go to this, and I sent this out, if you go right here, it's called a pacing guide. If you go to this pacing guide right here, blow it up, it tells you when every test is going to open and when every test is going to close. And it actually tells you over here to the right what chapters are on that test. Okay? That's called a pacing guide. 75% of y'all did not take test 8. And you know why you didn't take it? Because I didn't send out a text and say, you got a test that's closing on the 22nd. So here's grace. Here's a Christmas present. Here's I normally do not do this. Do you understand me? And the only reason is you got used to, and I hate to say I spoon fed you, but you relied on me sending a text. Okay, so I was sick and under the weather, so I wasn't able. So you're getting grace. So what I'm going to do is I'm going to open back up chapter 8, and it's going to close Sunday night. Do you understand? Now, if you are one of the 25% that took it, and maybe even took it twice, I will delete one of your lowest one attempt and allow you to have another attempt. Or if you want both of them deleted, then you got to send it to me in an email that you want both of them. Okay? But there's just a handful of y'all that wants that. All right. Now, so that's only one I'm going to do that on. And really, I'm not going to say I'm at fault, guys. Right there, it's in black and white. It's even highlighted. Okay. So let this be a lesson learned that when we provide you a schedule, let's make sure we adhere to it. Okay. So I'm gonna give you grace, give you a present. That's going to close Sunday. Okay. So if you are one of the 25% that did take it twice, and you want me to just wipe out your lowest one, let you try and see if you score higher, and if you do, I'll wipe out the second lowest one and let you do it for a third time. That's you just need to communicate that with me, okay? A lot of you didn't do it. All right, so that's test 8. What else? Oh, want to do this one thing. Want to show this one simple thing right here. And I thought about coloring it. I really did. But I thought, okay, I'm not. I colored it on your test, and we didn't cover it. This is called a combination. Okay, I think it's in chapter 5 is where it came at, chapter 5, but we didn't cover it in the material. All right, it's just something that I think another professor covers. The formula for this is n factorial over r factorial to n minus r factorial. So let me do this right here. Let me do this. Let's do this. Put some numbers for n and r. So we would do 8 factorial over 5 factorial times 8 minus 5 factorial. So what does that become? What that really becomes is this. It becomes 8 factorial over 5 factorial times 3 factorial. Okay. So what does it mean to have a factorial? A factorial is this. It's that number times everything below it. Okay. So what we're going to do is we're going to work a little bit smarter here. I have 8 up top, but I have a 5 factorial and a 3 factorial on the bottom. So if I do 8 times 7 times 6 times 5 factorial, look what happens on the bottom. See that 5 factorial that would cancel out up top, which would leave me with 8 times 7 times 6 over 3 times 2. That'd be 3 times 2 times 1. So if I do that real quick, let's do 8 times 7 times 6. That gives me 336 over 6. And I think that comes out to be 50 something. 330. Clear. 336 divided by 6. It's 6. So your answer would be 56. Okay. There's going to be a problem on the final exactly like that, but it won't have n as 8 and 5 as r, right? It won't have n as 8 and 5 as r. Okay. It'll have different numbers, but this is how you work it. I thought about culling it, but I thought, well, if I cull it, then that makes the other problems worth more. If I tell you what it is and allow you to practice it on the final exam review, right? And you know that's one that's going to be on the final, then you should be able to get that one and be able to score a higher score. Does that make sense? Yeah? Okay. So that's all I got right there. That's everything in a nutshell. There's a final exam review that you need to work on. Okay. You need to get that chapter or that test 9, which is chapter, is it test 9 or is it test 8? I can't remember. Oh, no, it's test 7. Chapter 9, that closes tomorrow. You need to make sure you jam up on that. Boom, get it done. Now, test 6, chapter 8 is going to reopen. So if you took it twice already, or you've taken it, one of the 25% that took it, if you took it once and you go and take it again and you scored higher, but you want to take it again to try to score another time, then let me know and I can delete it and your lowest attempt, and so you can have those 2 tries just like everybody else has having. But if you've taken it twice, let me know that you want to retake it, and I'll delete your lowest score so that you can take it again. And then if you want to take it again after that, let me know and I'll delete it. But that'll be stuff that you have to communicate with me on email, and you need to do it expeditiously. Okay. No, ma'am. Online. Online. Now, here's what I've also done. If you look at your final exams, let me go to quizzes and tests. Maybe I ought to go to that. $39. There'd be 40, but there's 39. I called that one chapter 12 one. Okay. And let's see if I go course home. Let me get into assignments. Let's see. Manage assignments. Okay. All right. So here you go. Let's this math final exam. So here's something I'm also going to do. I told y'all I'd do just the 10th, right, from 1 to 9. But I found out from let me do this. There.